Last video for this class for this week. So you made it to the last day of solving equations with exponentials. So take a look when you get to this point. What is really helpful is knowing a couple of things about numbers in terms of exponentials. So I would know your twos, which you know 2, and then 2 squared is 4. 2 to the third is 8. 2 to the fourth is 16. 2 to the fifth is 32. 2 to the sixth is 64. Same thing with your threes. It's helpful to know 3 to the first is 3. 3 to the second is 9. 3 to the third is 27. 3 to the fourth is 81. And 3 to the fifth is 243. God help us if we have to go that high. Okay, if we have 4 to the x, then it's helpful to know that 4, first of all, 4 is really 2 squared, right? And then to the x, just kind of keep that in mind. So if we have to use 4s, I mean, I guess, but I always try to go to 2s if possible. But 4 to the first is 4, 4 to the second is 16, 4 to the third is 64, and 4 to the fourth is 256. For 5s, 5 to the first is 5, 5 to the second, 25. You knew that. 5 to the third, 125, and 5 to the fourth is 625. So knowing these kind of is helpful for what you want to reduce your equations to, okay? So here's the key on solving equations with exponents. You want to get the bases to be the same. Because if I have 2 to the a is equal to 2 to the b, then a must be equal to b. Your exponents must be the same, okay? So then you can solve. So let's look at from number 1. So here I've got 5 to the first, but I can change that 125 to 5 to the third power, all raised to the x. Now, when I have exponents, that means I have 5 to the 3x. So this is 5 to the first. So I know that my exponents better be the same if I have the same bases. So I know that 1 has to equal 3x. So that x must equal 1/3. And we're done with that one. Okay. Take a look at this guy. They're telling you 3 is the base, so we'll keep the 3 as the 2p plus 1. But I know that 81 is 3 to the fourth. Okay, how do I know that? Well, because I just looked up here. Or you know 3 times 3 is 9, and 9 times 9 is 81. So that means you've got 4 3's that you're multiplying. And again, same base, same exponent. So I know that 3p plus 1 is equal to 4. So 3p has to be 3. So p has to be 1. Okay. Then for this guy right here, 2 is my base. 6 minus 3x is my exponent. And I'm going to change this. I know that 8 is 2 to the third power. So leave the 2 to the third on the inside. Put x plus 1 on the outside. Now, Algebra 1 review, right? Algebra 1 review. Put that off to the side. When you had x to the fourth power raised to the fifth power, you were allowed to multiply your exponents and say that that's x to the 20th, okay? The same thing is true except for this x plus 1 is your entire exponent. So this is 2 to the 6 minus 3x is equal to 2 to the 3 parentheses x plus 1. So those are the two things that you're multiplying. Same base, exponents must be equal. So I can come down here and say 6 minus 3x is equal to 3 times x plus 1. And I can go ahead and solve by distributing. I'll get 3x plus 3. And then 6 minus 6x, if I bring that 3 over, is equal to 3. And if I subtract 6, sorry, I'm going to get negative 6x is equal to negative 3. And so x is going to be 3 over 6, which is 1/2. Okay? So final answer there. And you can check your answer, right? So it might not be pretty, but we could check it. So let's check it, because I'm not convinced. Did I mess up my algebra? I'm sure you'll find a mistake somewhere. So 2 to the 6 minus, this is going to be 3 times 1/2, is going to equal, this will be 8 to the 1/2 plus 1. So I'm going to get 2 to the 6 minus 3/2 is going to be 8 to the 3/2. Okay. And 6 minus, what is that? That's going to be 12. So 2 to the, this is going to be 12/2 minus 3/2 is going to be 9/2. So 2 to the 9/2. And then is equal to, I'm going to change 8 to 2 to the 3rd, and then I have 3/2, and I get 2 to the 9/2 is equal to 2 to the 9/2. Check. I know I got it right. Okay. Now, when we start to get to this point, this gets real ugly real fast. So this is not necessarily ideal because now I've got some fractions in here, but I know I've got something to do with 5. So what I might do is I might, first of all, change this. This ends up being the cube root of 5 squared is equal to 1/5 to the x plus 2. Okay. And then I will go ahead, and if I have a root, that means I have 5 squared to the 1/3 power. So cube root and 1/3 power are the same. And then I have 1/5 to the x plus 2. Okay. So now I have 5 to the 2/3 is equal to 1/5 all raised to the x plus 2. So I don't have the same bases, but what I can do is I can rewrite this guy. 1/5 is the same as 5 to the -1. I can bring that 5 upstairs to the numerator, and then I have x plus 2, and here I have 5 to the 2/3. And then I'll simplify one more time. Whoops, not 3/2, 2/3 is equal to 5 to the -1 times x plus 2. So now I have these two, I have the same base. I can now set my exponents equal to one another. So 2/3 is equal to negative x minus 2. If I add 2, I believe I'm going to get 2 would be 6/3. If I add 6, 7, 8, I believe I get negative x is going to be 8/3. And then x is equal to negative 8/3. Now, if my arithmetic is going too fast for some of you, then pause the video and just take a minute and go through and make sure that you understand where this is coming from. Like, how did I go from here to here? Well, that's 29 years of teaching math and knowing fractions. You're still in your baby stages of your math career, and fractions are not your friends right now. You got to make them your friends, okay? All right, now, when we go to interest problems, go ahead and grab your calculator. Yes, I'm waiting. Take out your calculator. Okay. Now, there are two formulas that you have to know that have to do with exponentials. Okay. We already know the simple interest. We did this last semester in your word problems. Okay. What I want to focus on is this compounding interest, which tells us how much money we're going to have after we put it in a bank or in some kind of account that's going to earn interest, extra money. So interest, we talked about this last semester, is money that a bank pays you, or at least this is one way interest works. To keep your money in an account. Okay. They want to pay you money because then they're going to loan your money out to some other people and make more money off of that. Now, a couple things. This is the amount in your account. Okay. The principal, that's the initial investment. Okay. R is your interest rate as a decimal. Okay. N is how many times they are going to compound the money that you have. So number of times per year, or I should say, I don't even say per year, number of times your interest is calculated, or interest, I should say money is compounded. How about that? And then T is the amount of time. Now, each situation is different. There are times where you're compounded monthly. That's most banks. There are other times where you're compounded yearly, quarterly, etc. Okay? So let's take a look at this one. It says, find the future value and interest earned if this amount of money is invested at 5.3% compounded quarterly. So compounded quarterly. And I want to go for not 23 quarters. Let's go for 23 years. Okay. So let's take a look at what this means. We want to calculate how much money you have in the account. When you have 56,780 that you're going to invest, you've got 1 plus the R is going to be 5.3% is 0.053 over the number of times. Quarterly means 4 times per year. And then your N up here is again 4 times. And then the time is going to be 23 years. Okay, now we're going to go to our calculator and we're going to calculate this. So A is going to be 56, whatever you're going to do, you are going to calculate this. Go put this into your calculator, okay? And you can put this, raise it all to the 4 times 23 and get your amount. So right now, take a minute, see what you got. And remember, we're going to money. So money means we're only going to 2 decimal places. That is okay in terms of calc. When they're asking you to calculate your answer, if the answer is in money, they don't want it to 3 decimal places because that's less than a penny. They want it to the nearest penny. So go ahead and round to the nearest cent. Okay. So double check that you got everything in place. And it looks like I'm getting some probably huge number of money. Yeah, I got 190,000. So I'm getting 190,000. That's not a decimal place. That's $600 and 37 cents is what I'm getting. Okay. Now it says find the present value of 45,000 if interest is 3.6 compounded monthly for 1 year. I'm just going to set it up. So we want to know how much money there's going to be in 1 year. So we've got 45,000 is our initial investment. 1 plus, again, decimal places or decimal value for your percent, 0.36. Compounded monthly, there's 12 months, and they want to know for 1 year. Well, you've got it's going to be 12 times per year times 1. So go ahead and find that out. Okay. Now, continuous compounding. This is PERT. Okay. This is usually for population growth or decay. Okay. P is the initial amount. Okay. R, it could be your interest rate. We always also talk about it as what's called a proportionality constant. And T is time. Okay. So take a look at this. How do we use this? So right here, this is telling you that this started off with bacteria to be 500, okay? And they're already giving you all the information. So here, T is time in days. So what they want you to do is find the number of bacteria present after 2 days. So if I have to do F of 2, all I'm going to do is do 500 E to the 0.1 times 2, find out what that is, and go from there. Here, T equals 4. And 1 week, remember we're dealing with days, so T would equal 7. Okay, so done with the last day of your video notes. Enjoy your half day. You should be going through days 1, 2, 3, and 4 should be submitted after the weekend. Have a great weekend.